All right, it's recording. Settle down, it's recording. Here we go, exercise 3K. So I'm going to be going through mainly just algebra so far. So you've done algebra of exponents. You are introduced to logarithms last session. The key part of last session was so that you know how to convert an exponent into logarithms. It's not really conversion, it's actually just balancing the equation. Once you know that, that's going to help you understand how all these laws come from. Remember, like I said, in mathematics, you come up with a rule for a number system. When it doesn't work, they came up with a new system. This is the new system when you couldn't do the reverse of exponents. Logarithms is the inverse of anything with a power. Now, you're going to be learning mainly three laws. The first three are the ones that you're going to mainly use, pretty much all the way up to year 12. The hidden one, which most students tend to forget at year 12, is this one. And when I say, it is frozen. Let me just unfreeze that. Law number 1 and 2 are the most common, just like index laws. Number 1 and number 2, most students will remember. Number 3 is the one that examiners normally test students. And when I say test students, really we're talking about the state average, which the state average isn't really strong in terms of algebra. So number 3 is one of the key ones that I pick up straight away, whether a student is strong with their algebra. So we're going to look at that. But once you know law number 1, you know how to do law number 2. And then with a bit of thinking, you can then figure out where law number 3 comes from. 4, 5 literally comes from 3 and your logic. Okay, so you don't even need to memorize 4 and 5, but I'm going to write it down anyway. So your notes, let's write this down. Log law number 1, very similar to your index laws. Very good. So it is log base A of x multiplied to y. Okay, so very similar to index laws that when you multiply with the same basis, you add the powers. Interestingly enough, with the reverse, or with logarithms, it ends up being that when you add the logarithms with the same bases, then you multiply what's inside the brackets. And then similarly, again, with your index laws, when you divide exponents with the same basis, you subtract the powers. Well, in this case, when you subtract logarithms of the same base, yes, Andrea? Very good. In this case, it would then be log base A of x divided by y. Okay, so if you remember your exponents, then in the reverse, that's your logarithms there. The third one is the one they use quite a bit in your exams. For exam 1, anyway, it's the most common one that students make a mistake straight off. And I'll show you some examples later on why you have to use it or when you should use it. But law number 3, when you have the log base A of an exponent in the brackets, so notice all of these were x to the power of 1, x to the power of 1, y to the power of 1, y to the power of 1. But when you have x to the power of something, so x to the power of n, then the law says, do you know this one? Very good. You can bring the power down and it becomes n times the log base A of x. Okay, so that is log law number 3 that students tend to not use. And once you get pretty good at the rules in general, then I'll show you some examples of the year 12's why or where the mistake comes in. But law number 3, put a star next to it. It's one that you should try to use often, or where you can see it, use it. And then law number 4, which really is just an extension of law number 3. We know from exponents, instead of writing 1 over x, how can I write 1 over x in another way? Yes, Violet? Very good. So we think about that. This is the same thing as writing log A of x to the power of negative 1. But then you can use rule number 3. If it's to the power of negative 1, you can bring the negative 1 to the front. So the rule then says, well, if you have log A of 1 on x, then it's equivalent to negative log A of x. So if you think about the logic there, I'm just bringing the negative 1 to the front, and negative 1 times log, which is, again, n is negative 1. That's how you get law number 4. So if you understood law number 3, you don't have to memorize law number 4. It's just there. Number 5, A and B. Technically, if you understood what I taught you last session, you could probably figure this one out. What's log A of 1 equal to, Violet? 0. Why is it 0? Hands up if you know. The answer is 0. Thinking about last session. What is log A of 1 saying? Olivia?
Since like a to the power of 0 is 1, the opposite of that.
Very good. When you're reading logs, one of the skills that I wanted you to learn last session was that when you're looking at a log, you need to interpret it in terms of its powers. Because remember, log is just finding the power. So whatever the result is, it's saying a to the power of what will equal to 1. That's the language. Yeah. So here, if I wrote it out as an exponent, it was pretty straightforward. If I had done a to the power of what equals 1, most of you would have known the answer 0. Now you do the same for the next one. A to the power of what will equal A? Yeah. And that was last session, was trying to get you to link between exponents that you're familiar with and reading log. So the challenge is that little gap between the two. When you see this, it doesn't mean anything. When you look at this, it means a lot to you. So we read it. This is actually really saying A to the power of what equals A. Because remember, logarithms is to solve the power. Exponents is to get the result. So the reverse of that is just finding the power. So every time you write a log, you're saying a to the power of something gives you x to the power of n. A to the power of what gives you x. A to the power of what gives you y. That's essentially what each of these are saying. Okay? Now that we've got the log rules, let's see the proof for the first one, just so that you can see how exponentials becomes logarithms. Here's a quick, easy proof that you guys can actually run through. Let's start off with, I got the bases, the same two exponents. A to the power of m equals x. Pretty straightforward. A to the power of m, I don't know what m is, but I know that it's going to give me a result. Let's call it x. Then I do the same thing again. I keep the same base, and I say a to the power of a different number, and it gives me a different result. So a to the power of n equals y. Now, let's use what you learned last session. I want you to convert this to an equivalent logarithmic expression. Okay, you can use balance in the equation, or you can do the conversion the way I just did before. How would you rewrite this as a log? Hands up once you got the answer. Sanvi.
Is it log A x equals n?
Yeah, wait. See, yes, you're right. Log ax equals m. I'm the one that got it wrong. Yes, you're right. So again, it's a to the power of what gives you x. In this case, we knew the power is m, so a to the power of m equals x. That's one expression. What's the other one?
Log A y equals n.
Very good. Log a of y equals to n. Now, the reason why we're doing this is because we are rewriting what would the power equal to. M will equal to log a of x. N will equal to log a of y. Okay, now let's do a bit of a proof. Log law number 1 says that if you multiply log a to the power of m, times a to the power of n, index law number 1, what do? You add the power. So let's rewrite this. This is the same thing as writing a to the power of m plus n. But we said before that a to the power of m is equal to what? No. Look at what we've got so far. What is a to the power of m equal to? Yeah, it's literally up here. A to the power of m equals x. So technically, I can be saying x times, what's a to the power of n equal to? Y. That's what I said here. I said a to the power of n equals y. So that's a to the power of n. So I'm going to write here y. So what you really have is a to the power of m plus n is equal to x times y. Now, whatever x times y is, I don't care. It's a number. This is a to the power of m plus n. Now, can you see how it's very similar to what we just did just now? If I asked you now, can you convert this to a logarithmic expression? What would it be in this next line? Just like you did over here. What would this one be now? Have a go. Put up your hand if you got the answer. You know.
Is it log A times a to the power of n plus n?
Oh, yes, that's how you do it. Yes, that's the how. So log, to do the inverse of exponent base a, then you do log base a on the left. And what if you do to the left? You do to the right. And what answer do we end up with? What's the answer? So Eunice, correct? This is what I taught you last session. to get rid of that base A exponent, you do the inverse, which is log base A. So whatever I do to the left, I do to the right. And then that, remember these are inverses, so they cancel out. And my next answer is m plus n is equal to log base A of x times y. Yeah, so this is what I was teaching last session, where the logic comes from. We're just balancing the equation. The inverse of exponent base A is log base A. So I did to the left, so I'm going to do it to the right. Log base A of xy, that's what this line is. Now what's interesting is you're almost there at the proof for log law number 1. I've got log A of x times y, but remember we did know what m and n is equal to. We already made it up here. We said m is equal to log base A of x, and we already said that n is equal to log base A of y. So that means if I replace it all, this now comes down and says that's log base A of x plus log base A of y. And that's where log law number 1 comes from. Cool, so log law number 1, if you go back and you have a look, we said that log base A of x plus log base A of y should equal to log base A of x times y. And I've shown that. If you understand this sort of process or understanding of what I'm doing there, you can technically prove law number 2. Law number 3 gets you to think a bit. Just a bit, just one small different step. But that might be something that you can have a go once you're feeling a bit more confident with log laws. But that's just to show you how the relationship between exponents and logarithms work. And really the key that I wanted you to learn from last session was that. Exactly what you were doing just now, knowing how to move between exponents and logs. That's the first skill. Okay, once you got that, then the stuff I teach you makes a lot more sense. Okay? All right, let's say a typical student generally will not know what I just taught there, and that is very confusing. So they will memorize this. Okay, so they'll memorize these laws, and you can memorize it. Most students, like I said, will only remember the first 2, and then they'll forget the rest. Ideally, I want you to at least learn the 3. Okay, so remember the first 3. So let's apply it. Let's do an example. Here we go. Simplify the following expression, answers in log form. So they want you to collect it as your final answer should just be log base A of something, right? So let's have a look at this one. If I have log base A of 3 plus log base A of 8, that can be simplified to, Violet again. Very good. So this is using which law? Which law, Andrea? Law number 1. Very good. So law number 1, if you're adding 2 logs but they have the same base, you can then times the insides together and you should get log base A of 24. Very good. Testing you again. If you were to write this as an exponent, what is this really saying? Hands up. What's log base A of 24 really saying, Sanvi? Beautiful. A to the power of what equals 24? That's what that is saying. Okay, so once we know the base, then it's A to the power of something must equal to 24. Right? Next one. 2 times log A of 4. What do we do here? Let's go with Sanvi again. Sorry? Very good. So we've moved the 2 to the top. Log base A of 4 squared. Which law is this? Hands up. Let's go with someone new. I'm getting only 3 students here. Sean. 3. This is log law number 3. Okay, so law number 3, we can bring the 2 up. And this is one of the first things that the examiners do. That typical example there, all they do different. This is what they do. In the exams, they'll probably keep it all the same. They'll probably give you a number. So it might be like 2, for example. But then they'll do log base 2 of, say, 32. What do you think most students would do at this step here? What do they go wrong in the state? State average, they'll get this wrong. And they'll chuck it in. What's the problem? What's the first step do you think most students would do? You guys did the right step. What's the wrong step? So if I asked you, imagine if I just wrote this out and I said, simplify that. What do you think most students would do first? You know. This is what most students would do in the state. We can find that in some past exams. All exam ones, generally question 4 or 5, they'll have a log on exponent question. And that right there, you cannot do. You cannot ignore that 2 and say, yep, that is log law number 1. I'm just going to do 4 times 32, and then keep the 2 at the front, and then whatever 4 times 32 is. That's 128. And that was right. 2 log 2, 128. This is exam 1, so no CAS calculators, and they leave their answer there. Okay? That is wrong. The first step here is not true. Your log law never said that I can use this law when I have a number, I don't know, n at the front. Never said that. Okay? It always said it is literally just log a of x plus log a of y. Never said a coefficient. Okay? So there shouldn't be a term at the front. So that's usually the first thing that examiners test. And then they vary it. They put a fraction in there, they put a negative at the front, they put a fraction in there, maybe a third. Regardless, you got to do rule number 3 first. Okay, so in order to solve this problem, if it was an exam question, you needed to convert this one to log 2 4 squared. Then you can do that. That would have been the correct step. Then you can times these two. Okay? But in this case, you are only starting off, so for this answer, yes, you guys are right. It is log base a of 4 squared. So your final answer is log a of 16. Okay? And again, if we were to interpret that, that is saying a to the power of what equals 16. Okay, so get used to reading logs. When you say log base a of 16, that really is just saying a to the power of something is equal to 16. All right, let's flip over some problem-solving skills here. Flip over the page. Let's test your understanding. Got 2 more problems. Here we go. Simplifying using a combination of laws of logarithms. Look at the first one. This could be an exam question, but this looks a bit too easy, but still has the same essence. What do you have to do first? What's the key thing? Yeah, I know you have to simplify. Log law number 3 on this one. Don't leave the half at the front. You can't combine these two. Just because you have a takeaway and the same bases, you have to get rid of that half first. So that half, log law number 3, bring it to the top. So what you get now is log base 5 of 3, take away log base 5 of 9 to the power of half. Now, using your understanding of exponents, 9 to the power of half is the same as what, Yuna? Oh, yep.
When you move the half, would the sign become a positive?
Oh, no. So yeah, we only keep just the value. The sign we always keep there. Yeah. But you could, if you wanted to, you could take that as negative half and then that becomes plus. That works as well. Yeah. There's nothing wrong with that. It'll still work. 9 squared. Yes, it does become 3. I think you meant square root. Is that right? Yes. So remember from what we learnt in exponent law number 8. Remember that I said that most students forget law number 8. A to the power of m, that's the nth root, is equal to a to the power of m on n. That 9 to the power of half is the same thing as saying square root of 9. And if you didn't know that, you can still change the base of a 9 to simplify that further. So, this now becomes log base 5 of 3, take away log base 5 of, and remember 9 to the power of half is the same thing as saying square root of 9, which is 3. What do we do now? What's the next step? Yes. Very good. What law is this, Jaden? What does Sahar just do? She just said log base 5 of 3, take away log base of 5 of 3 becomes log base 5 of 3 on 3. Which law is it? Law number 2. So law number 2, you can use it now because there are no coefficients at the front. But then 3 over 3 is 1. But we know what log 5 of 1 equals 2. So remember, interpret it. This is saying 5 to the power of something equals 1, and the answer is, Andrea, 0. Because if you interpret it, this line is just saying 5 to the power of what equals 1. We know the answer is 0. Otherwise, you can memorize law number 5. Okay, so 5a or 5b. But if you interpret it, you don't have to memorize it. Okay? Next one. I'm going to pause the video. I'm going to give you, how long should you take? I reckon you should only take maximum 3 minutes. Let's go. I'm going to pause the video, and that's the last example. 3 minutes. Have a go, and then we'll